We have an 8-step process we like to apply to physics problems. To approach a acceleration word problem, the first thing you should do, step 1, is to draw a large picture with a XY coordinate axis. A lot of students will like to draw a microscopic XY axis, but that's not good. You go ahead and use a lot of space and just draw a picture of the scenario with an XY axis. A lot of students love to leave out the coordinate system, but it's actually extremely important because it's what tells you what's positive and negative is your choice of coordinates. So you always want to see a big picture, big coordinate system. Okay, so like if it's a car starting from rest, put your car at the origin, it's fine, it doesn't have to be fancy, and then maybe it's accelerating down the positive x-axis, right? 2, what I want you to do is go through and draw your car and put in a vector. If it's accelerating, right, like or a velocity, we're going to put in like a velocity vector, an arrow pointing the direction that it's going in. Then we're going to write down everything that the problem has given us and what it's asking for. And so the things you want to write down are the following. You want to write down initial position, initial velocity, final velocity, acceleration, and time. So you can just make a little just a list. Okay. Some of them you're going to be given, some of them you're going to be asked to find. Basically, anything that the problem gives you, you write down. At rest is code for initial velocity 0. You can put a 0 in if it says at rest. A lot of them start at rest. So you fill that all out, and then you pick one of the 3 kinematics equations based on what you know and what you want to know. Usually at this level, you'll only need one of them. Your options are V final velocity equals initial velocity plus acceleration times time. That one gets used a lot. So for example, if the problem said an object starts at rest and accelerates at 2 meters per second squared for 3 seconds, how fast is it going? Okay, well, let's fill out our chart, right? It would be initial position, we can call 0 because we're going to put the car right on the coordinate origin. X final, didn't say anything about that. We're not going to use everyone every time. We can just put an X there because final position, wasn't asked in this problem or given. Initial velocity, remember how I said that at rest is code for initial velocity is 0. So we put a 0 in there. V final velocity, that's what they're asking for, the final velocity of the car. So I'll put a question mark there. That's what we're trying to find, right? And then T, time, they gave us 3 seconds. And then you look at your 3 kinematics equations, and you'll notice the one that I listed, V final equals V naught plus AT. It has all stuff that you know, plus the one thing that you're trying to find out, right? You want to find final velocity. Okay, so you pick that equation, again, because you pick the one that has all things that you know and the one thing you're trying to find out. You plug the numbers in, so you get V final equals 0 plus AT. I think I said A was 2 meters per second squared times time is 3 seconds, and you get 6 meters per second. This is where you can check your units to make sure that they work out, right? Because you have an acceleration meters per second squared times the time. Seconds cancel, you get meters per second, and the units worked out. And that would be an example of one problem. But the process that I just went through is the same for all of them.